Okay, in this video we're gonna try to prove that the integral of f of x dx between a and b is c times b minus a, where c is the value of f of x. In this case, c is just a constant. That means the function is the constant function c on ab. So we can apply the Riemann's sums for the integral. So we have a b f of x dx is the limit of delta x f of, let's say, the sum k from 1 to n f of ck. We need, and as n goes to infinity, we need to define delta x and ck's. Okay, so here we will have a picture. So on this interval ab, where our function is constant, our f is equal to c. So this is the interval ab. So this is c, the value of the function. Okay, what we do to get the area is that first note that the area of this rectangle is just b minus a times c. So this is what this one is saying. Okay, we're gonna prove it in a different manner. Okay, so this is using algebra. So b minus a is this length times this one, which is c. So that means b minus a times c. But for us to use Riemman sum, we're gonna do subdivisions. So this is x1 and this is xk, this is xk plus 1, where the xk's are defined as a plus k times b minus a over n. These are the subdivisions. Okay, so let's say we get n once. Okay, so here this difference between xk and xk plus 1 is what we call delta x. So we're gonna split this rectangle into small rectangles and we're gonna add them. So the area here is what? Is delta x, okay, which is this one, times c. We're gonna add all these rectangles. Okay, so that's what we mean here. So we make these rectangles very small to be precise. Okay, so let's rewrite this one. In our case, delta x is just b minus a over n. It's this length here. So if you make the difference between xk plus 1 minus xk using this formula, you will get b minus a over n. Okay, therefore this integral becomes the integral between a and b of f of x dx is equal to the limit as n goes to infinity. So now delta x is just b minus a over n, and f of ck's, the ck's are this point, or the xk's are these points. So since these points, the ck's or the xk's are the same, so their image is just c. Okay, the ck is, the image here is just c. But we forgot to add the sum from k going from 1 to n. Okay, so let's rewrite it one more time. The limit b minus a over n, this is sum k from 1 to n of c. Why? Because f is constant and it's equal to c. Note that the image of every element is just c. So we have this one here. So now let's take the b minus a to the front because it doesn't depend on n, and we have the limit of 1 over n sum from k to n of c as n goes to infinity. What's this sum here? So this sum is how many times we have n? We have c. So this is the sum of c between k going from 1 to n is just nc. So we summed c n times. Okay, therefore we have the limit b minus a, okay, the limit of nc over n as n goes to infinity. And we take the c outside because it's constant. So it's going to be c times b minus a. Let's forget the n. So b minus c times b minus a, the limit of n over n. That's 1. So it's 1 because this is a constant. It's 1 over 1. Therefore, our limit here is just c times b minus a. And this proves that our integral in this case is just c times b minus a. And that's what we see in the book, okay? So that's the Riemann sum, the proof of the Riemann sum, okay? So I think that's all we need to prove.